You wrote the DynamoDB book. Like, you're the DynamoDB guy.
I kind of fell into it by accident.
Do you ever see yourself going back to a full-time job? Welcome back to another episode of the Backend Banter podcast. Today, I'm joined by Alex DeBrie. Now, Alex, I think I first became familiar with like the stuff that you're working on through the serverless framework, which we'll talk about. But the primary reason I invited you on today is to talk about DynamoDB, which is a database that's tightly coupled with like the AWS ecosystem that I've never used. So hopefully I can ask a bunch of interesting questions. We'll be able to discover some things we haven't talked about yet on the pod.
Gotcha. Well, you already have a few knocks against you there just by admitting you haven't even tried out Dynamo. But no, I won't hold that against you. It's very like niche and interesting and different. And yeah, a lot of people haven't. So, but that's great. This will be a great conversation. I
hope it'll be fun. I should be able to do a lot of compare and contrast against like the databases that I am more familiar with, like Mongo, Elasticsearch, Postgres. We'll see how that goes. Yeah. But to start, do you want to take just a second and introduce yourself? Tell us who you are, what you've worked on in the past, that kind of stuff.
Yep, sure. So yeah, my name's Alex DeBrie. I think sort of started being in the community and things like that when I worked at Serverless Framework, as you're mentioning. So I worked for Serverless Framework for 2.5 years and just like got involved in the AWS and serverless community from that. As part of that, started working with DynamoDB a lot and sort of like accidentally fell into went deeper and deeper into Dynamo and like wrote a website about it and then started doing talks and then wrote a book about it. And then now for the last 4 years, I've been mostly an independent consultant, Dynamo, serverless, AWS, just different things like that. So that's mostly what I work on these days.
Oh, cool. So you're actually at the moment like on your own doing the consulting thing.
On my own, yeah. Been on my own for most of the last 4 years. I had like a brief five-month stint in the middle of that, but yeah, mostly on my own for the last 4 years.
Okay, wow. We might have to touch on that as well because we've talked about consulting on this pod before, but like I haven't really had a guest that's done too much of it, especially in like recent years. So we might touch on that as well. That should be fun. Okay, so let's dive right into Dynamo. Like, first of all, what is Dynamo? Our listeners are familiar with Postgres. Maybe they've heard of Mongo, but what is DynamoDB?
Yep. So I like the short phrase I say is it's a fully managed NoSQL database from AWS. So NoSQL database people kind of know and understand, although I think it's actually pretty unique from a lot of the other ones. But like one thing that's interesting is like it's from AWS, so you can only use it on AWS. Because of that, it's fully managed in a way that most databases aren't fully managed, right? Where it's not like you're sort of picking a server size and server class and different things like that. And they're like managing it for you somewhat, but also like you're still in charge of certain things, maybe some backups or at least configuring backups or different things like that. Like Dynamo really is more fully managed for you. It's more like S3 or SQS than it is like than RDS. And it's a little different from S3 because like S3 is like, hey, you can just start throwing as much data as you want into it. Whereas Dynamo, you can have provisioned capacity where you have to set like how much you can do per second, things like that, or you can do on demand mode. But I'd say it's more like those. It's a multi-tenant service where like, behind this, like they're giving you an endpoint but behind the scenes, they've got like a bunch of different microservices that are working together and sort of everyone's data and metadata and all that stuff is using the same shared infrastructure like in S3 rather than RDS, where it's like, if you spin up a Postgres instance, theoretically someone could take you to a data center and like point to a database and say like, your RDS instance lives there. That's like not true with Dynamo, right? It's spread about a bunch of machines. Okay,
so you threw out a bunch of products there. I want to just like recap a little bit. Let's like go way back to first principles. So like, let's say I have an EC2 instance and it's just like this VM running in the cloud. So it's like this box in some AWS data center. I could install a database on that box, like a MySQL or a Postgres. And this, to me, would be like the least serverless thing ever. This is the most serverful thing that I could have, right? And I got to manage that box, and I got to like install the stuff, and I've got to upgrade dependencies, and I got to do my own backups. When AWS launched RDS, branding was kind of like, this is a managed database. You use that term as well. I think it's a great way to describe it. But like, and it is like you buy this RDS box, and now instead of just like a vanilla Linux server, you get this Postgres database, you get a way to connect to it. Versioning's done for you automatically. You can like check some boxes to get backups automated. But like you could still go find your RDS database in an AWS data center, right? Like it exists in a server somewhere.
Yep. It's like a specific thing. You're connecting to a specific thing. Like they will give you, you know, an IP address or like some sort of long domain name, and you're connecting to that specific server directly. Like you're saying, like there's going to be upgrades on that specific server directly and things like that. Or if that specific server had some hardware failure or something like that, like you would notice that as a particular user, even though that's like a managed service, like you specifically as a user are going to have problems that maybe the person next to you wouldn't have as they migrate you to a new server or failover or things like that.
And S3 is like more like the fully serverless thing of like, at least my experience with S3 is like, I'm given some URL to point to, but it's not like the URL of a specific VM. It's just like the URL of S3. And then I just tell it which like key value pair I want to store things in, like shove all of this data into this key, and then I'll come back and get it later. Backups are, I'm assuming there's a ton of redundancy that's just built in. Like you don't have to worry about that yourself. So is Dynamo, it sounds like Dynamo's more like S3?
Dynamo's more like S3, where it's like a region-wide service, and you're going to be connecting to the service rather than to a specific server for your sort of like data plane operations, right? So you'll be connecting to dynamoDB.useast1.amazonaws.com or whatever like that, doing those operations. And then there's, you know, there's load balancers that are forward to request routers, and then they'll sort of look up the metadata for your specific data and then figure out like which storage nodes and which specific servers it needs to go to read data or write data or things like that. But it's like a more multi-tenant region-wide service that AWS is truly fully managing for you, rather than a more server-based one, even a managed server like RDS, Postgres or MySQL, or even like DocumentDB, or if you use MongoDB Atlas or anything like that.
It feels like maybe the like non-programmer analog would be almost like using a SaaS product or like a Google Drive, where it's like when you use Google Drive, you're not really concerned about where exactly the data is getting stored. You just kind of upload it to Google Drive and trust that later you'll be able to get it off of Google Drive somehow.
Yep, exactly. I think that's a great comparison. Google Drive is more S3 like, you know, directly, but like it's in that same sort of vein, I would say. Yep.
Yeah. So Dynamo, like that is a key difference between Dynamo and S3. S3 is like kind of raw. We call it object storage, which is kind of like a different version of file storage, but it's like pretty raw. You're just like shoving stuff into it, uploading files. Like for example, on BootDev, we use the GCP alternative, but it's the same exact thing as S3, which is like we're uploading images. So like your profile images, they go into that object storage and we serve them from there. So with Dynamo, it's more like a database. It's like we'd compare it to a Mongo or a Postgres. And the thing you said earlier was this is NoSQL. To me, that feels like the most useless term ever. It's just not SQL. Like what do we mean when we say NoSQL?
Yeah, exactly. So yeah, I had that phrase earlier and I talked about the operational aspects and sort of that stuff, but like the sort of modeling and developer and user aspects of it. So it's a NoSQL database. Again, like you're saying, bad term, sort of came out in the 2000s, where like, you know, everyone's using traditional RDBMS relational databases. And then you had this sort of new wave of other type of databases, MongoDB definitely being the most popular of those, but you also have like Cassandra. Weirdly, like Elasticsearch is probably in there, which is like its own funky thing. There's not a lot of like, you know, what makes it NoSQL. I'd say probably like the main through line for all of them would be like easier to shard your data and split it across multiple machines would be some of it. And given that, relaxing some of the traditional relational features you have, whether that be transactions, whether that's like schema enforcement type stuff, foreign keys, joins, like giving up some of those type of features in order to like shard more easily, which means, you know, theoretically scale more easily and things like that.
It can be web scale.
Exactly. Like all that sort of stuff. It's been weird now, I think, over the last 10 years, because I think a lot of the NoSQL ones have moved a lot closer to their relational database counterparts, right? They're adding joins, they're adding aggregations, they're adding transactions, different things like that. And I mean, Dynamo has transactions too. So I think honestly, a lot of the databases, whether that be MySQL, Postgres, Mongo, Elastic, I think those are more similar to each other than Dynamo. I think Dynamo is like way off on its island in like a different realm of things generally.
Is it also very different from like BigQuery? Because BigQuery is also like this kind of serverless managed thing in the Google world.
Yep. And I always get confused. Okay, so BigQuery is more like the OLAP-y one, right? Like a little more like OLAP, like aggregation type queries. Is that right?
It's pretty rare to use. And so like now that you say that, I'm like, okay, yeah, obviously the things are pretty different because with BigQuery, you wouldn't really use it for like a transactional application. You're more like running analytics on it.
Yeah, exactly. But Google does have, is it BigTable? And I think that's actually like fairly close to Dynamo. So the BigTable is like closer to Dynamo. I would say like operationally, both BigTable and BigQuery, if I understand correctly, I think are more similar to Dynamo, where it's like more multi-tenant type stuff and you're not provisioning servers. I'm not 100% on that because I don't do a ton in the Google world, but like BigTable data model wise, I think is going to be closer to Dynamo.
Experience with BigTable. Well, I want to hear you talk a little bit more about Dynamo because I'm definitely not an expert on Dynamo, but like in the, just to like set the tone for the comparison, I have done BigTable. We did this really dumb thing at this company I was at. This is a fucking terrible idea. We used BigTable as like our CRUD database for just like generic CRUD services. And BigTable has some weird constraints on it that, in my opinion, do not lend well to like a startup trying to build CRUD application because it's very key value store. But the weird thing is that the keys, you can kind of sort them, but like they're lexicographically sorted. So all of the conversations we had at this company around like database model was just like, get the key right. Like we have to make the keys in the proper order so that we can sort correctly. And if you F up the key, the only thing you can do is like copy the data into a new key structure.
Oh my goodness. So you could have just substituted BigTable there and entered Dynamo. Like that
oh God.
Dynamo.
Okay. It's the same thing.
It's like the exact same thing. Yeah. And that's why like Dynamo is super weird. There are pros and cons to Dynamo. I'm like, I love Dynamo for certain things, but then there is like, I don't begrudge anyone that doesn't use it because it is weird and different. And especially like if you're talking in that startup flexibility type world, it can be restrictive and limiting in that sense. So
it scales like crazy, right? Like that's why Google uses BigTable to like run Google is like, the scale is enormous.
Exactly. I mean, like the nice thing about Dynamo is like, you're just trading off a different, you're getting these sort of like operational and scalability benefits, and especially like predictability. Like basically once you sort of model it in a certain way, you know that like, hey, it doesn't matter how many concurrent queries are being run, or if someone's running a giant aggregation query, or if we have way more users or way more data or anything like that, you know, you're going to get the same predictable performance for a given request when you have 10 users as when you have 100,000 users, when you have a million or 10, a billion users, whatever. It's going to be predictable in that sense, but you lose a ton of the flexibility that you get from that relational model. So I get the upsides of that as well.
Let me ask this question. After I used BigTable, I would not recommend using it as like the main CRUD store for like a typical SaaS application, right? But I can definitely see use cases for it, either like when your CRUD application gets so large that you just need the scale benefits, or you have like a specific part of your application that has specific data needs, right? Like maybe it's not the main CRUD part of your application, like users and groups and organizations and billing, but maybe it's like, you know, we're piping in social media data and we have like this massive amount of data that we just need to store somewhere, and we kind of need to maybe like sort by timestamp or something. When do you think about using Dynamo? What are the use cases that are big?
Yeah, it's interesting. I think that like small focused one is really, or like a lot of data, but like fairly simple model, like you're saying, key value, or like, you know, groups of data that you need ordered by timestamp. That's really good. I see people use it for sort of everything, and you absolutely can. I think one of the reasons Dynamo took off, the reason I got into Dynamo was because it worked so well with serverless applications, especially in the early days. Just like for a lot of reasons, if you were using AWS Lambda, it did not work well to use a more like server full database like Postgres, MySQL, Mongo. Again, anything that had like a specific server that you could point to. And part of that was around connection limits, right? A lot of those, because they're a single server, they're often limited in how many connections they can have to them, right? And MySQL's gotten better at that. Postgres has gotten better at that, but it's still like usually you don't want to have a ton of those, which usually you solve with like connection pooling in your application layer or something like that. But if you have Lambda functions, now it's doing like one request per function. Each one is doing a connection. Like you can't hold those open. So that was a problem. I'd also say like, often you want to have those database resources in a VPC. Again, since it's a specific server, you want to sort of protect it from outside internet traffic and things like that. It used to be a real pain to put Lambda functions into VPC, like serious cold starts and just like an operational pain. That's gotten better as well. And then also just like some provisioning and permission steps where it's a lot easier to use Dynamo than it is to use a relational database with that. So a lot of people did that, and a lot of people built their applications on top of Dynamo, including the core of their stuff. I will say like the core of your application that, like you're saying, users and groups, it has like many-to-many relationships. You have flexibility. You have people changing their usernames or emails or things like that, like more mutable data. That can be tricky. And that's like where you might want to think about it a little bit and see what your appetite is for something like that. So it sort of depends on like what constraints you want, what operational profile you want, different things like that.
I love that you brought up the constraint of number of connections, because at least when I was a new developer, I assumed that usually with a database, the things you'd run into most quickly are like running out of CPU on the database, running out of memory, running out of disk. In fact, I think I really overestimated the problem of disk. Disk tends
Right.
to be like
Disk
not a problem
cheap.
at all.
Yeah.
You just add more disk. Like that's not like CPU memory. The thing that like kind of caught me by surprise was how often the number of connections is actually the problem. In fact, we just ran into this on boot dev a few months ago. What was happening was our backend's written in Go, and we'd have like it's a CRUD application, it's a JSON API. We'd have a handler, and in the spirit of optimization, this handler would make like, I don't know, let's say 4 different SQL queries. Each query could be ran in parallel. So we were spawning a Go routine for each one and making a database query in each Go routine. What that does under the hood is open 4 connections to the database, right? We were using like the built-in connection pooling and stuff, but when we started to have more traffic, like we were hitting Postgres is like default connection limit on like Google's RDS equivalent cloud storage or Cloud SQL. It's like 100 connections. It's like that many,
250
right?
or like 250 or 500 is like where it starts to like really even blow up. Although I was talking to someone yesterday and he says it can easily do thousands now, so we'll see. But yeah, it is like much lower than you would expect.
Like I probably could go update some configs, right? Like I'm using whatever the defaults are at the moment, but like defaults are there for a reason, right? Like you don't want to like overuse your hardware or whatever and get actual crash loops going on. Yeah. But I was just kind of blown away because our CPU and our RAM usage were still like crazy low because our queries were fairly efficient, and it was just like we have 15 people on the site at the same time. They're hitting these handlers that are opening 4 connections each. Like blows up.
Yep, hitting those issues. Yeah,
it's a real problem that it sounds like you know, using Dynamo or I'm guessing like Spanner or BigQuery or BigTable or whatever, it takes care of some of that.
I mean, I think the big thing with Dynamo, the reason it doesn't have those issues is, again, it's a multi-tenant service. You're not hitting a single server. You're hitting a fleet of load balancers that can terminate connections that then go to like request routers, and those are both like stateless layers that they can just scale out infinitely and all that sort of stuff. So then it's like you don't need to worry about overloading your individual service. Whereas like Postgres, they're gonna create a new process for each connection you have to it, and that requires resources on the server, and that's why they want you to limit the number of connections you make to it.
That makes perfect sense. Okay, cool. So we've kind of contrasted it a little bit, especially like against some of the SQL databases like Postgres or RDS, I guess in particular. Which anyone listening, like RDS is AWS's managed version of SQL databases. So I think, is it just Postgres MySQL, or is there? No,
they have Oracle, they have SQL Server, and they've recently announced support for DB2. Have you used DB2 ever?
I have not. I forget about Microsoft and Oracle sometimes.
Yeah, me as well. But yeah, at reInvent this year, they had support for DB2, which I imagine that's just like a bunch of migration, moving on-prem to the cloud use cases. They want to support that. Probably not a lot of people like spinning up new DB2 instances these days. But
so how does it shake up against something like Mongo?
I think they get grouped together a lot, and they're actually quite different. I would say like the comparison I always have for like Mongo versus Dynamo is like, Mongo is libertarian and Dynamo is authoritarian. So Mongo lets you do anything. Will let you like write any query you want. And again, let's go back. Like a lot of these NoSQL databases, they're splitting your data across shards or partitions or something like that. But if you have, a 100 gig database, maybe you have, 3 shards of 3 partitions and each one holds 30 gig or something like that, right? 33 gig, something like that. They're splitting across these different storage nodes, and they're often going to be splitting by some sort of key. And ideally that key is used in your query to sort of, so when a request comes in, it can just say, oh, I just need to go to this one shard and do that query there, rather than hitting all the shards to handle that sort of query. Mongo won't enforce that. Mongo, like if you write a query that needs to go across all your things, it's just that query will come in, it'll go to all 3 of your shards or all 10 of your shards or however many you have, sort of fetch those intermediate results there, go back to the router. It's going to like combine those results and figure out what you want and then send you the final result, right? Which means if like most of your queries are like that, it means that horizontally scaling isn't going to help you as much, because if you add another shard on there, well, all those shards are still getting all those queries. So like continuing to further shard, you're still going to have like this baseline level of usage that's going to all the shards. So you're just like not going to get as much bang for your buck there. Dynamo, on the other hand, is like going to religiously enforce that basically you include what's called a partition key in your data access patterns. And that partition key is how they're splitting your data. So now when you have a request come into Dynamo, it hits that request router. That request router can say, okay, this partition key lives on this specific partition. I'm going to forward it there. And now only that partition is involved in servicing that request. And that means like as your database grows, they can add more partitions and you get essentially like linear scalability, right? Because you're not doing multi-partition reads or writes generally for that sort of thing. You can use Mongo like Dynamo and only write queries and model your data so that it's only hitting a single shard and sort of getting that linear scalability. Or Mongo's going to let you do whatever you want and like do these sort of like scatter gather type queries where they're hitting all the shards in parallel to like fetch and handle that specific result. And now you're not getting all those like horizontal scalability benefits that NoSQL is sort of aimed at, but it is giving you a lot more flexibility. Whereas like Dynamo, if your access patterns change, or if you have a query that needs to span across your database or across like larger chunks of data, it's a lot harder to do. You're sort of like manually doing it yourself in different ways.
I don't know, like this analogy is not going to be perfect, but okay. I think it'll maybe get us somewhere. You know how like in a dynamically typed language like Python, you kind of just do whatever you want and then like maybe it works. Yeah. Whereas like in a statically typed language like Go or TypeScript or C or whatever, forced by the compiler to like adhere to certain ways of writing your code. And then if it compiles, like it's, you're kind of eliminate this whole set of problems when you run the thing. My experience working in Elastic and Mongo is like you can kind of like write any query. Not guaranteed to be fast. You have to run it and like see how fast it's going to be. It sounds like Dynamo might be more similar to like we already talked about BigTable. I think another analog might be Firebase, which is like you have this really restrictive way that you're allowed to query the data, but when you do query it that way, it's kind of guaranteed to be fast, right? You're not going to have this like, I don't know, 2 to the n blow up on, the efficiency of the query. Like you said, the trade-off there is you have to be extremely strict about or rigorous about how you structure the data, because if you want to change it later, at least, and I don't want to put words into your mouth about Dynamo, but like my experience with BigTable is like you basically have to copy the data into a new format. Yeah,
like if you want to change the primary key of of an item in Dynamo, you can't just update the primary key. You do have to copy that into a new item. Now, Dynamo does have like secondary indexes where you can like, add a secondary index and basically reindex that data in a different way that allows for different sort of read-based access patterns on that. And that, like, just side point here, one thing that's interesting about Dynamo and Mongo there is like, if you add a secondary index in Dynamo, it's going to copy your data onto different partitions, right, for that secondary index, like in a different shape. It's going to do that asynchronously. So when you write an item to Dynamo, it's going to write it to your main table with that main primary key format, but it's also going to asynchronously replicate it to these, to your secondary indexes, which are like on different partitions elsewhere. So again, when you query that secondary index, you're getting that same thing where it's like, okay, which partition is this on? I can go right there and get it very quickly. And you still get that like consistent performance on that for that secondary index. Whereas Mongo also lets you set up additional indexes on your data. And if you happen to index on something that doesn't correlate with your shard key, it's going to be indexed locally on each shard. But now when you do a query, that's when it has to fan out and hit all those different shards, and they'll each read their indexes to do that. So like Dynamo sort of like forces you into that. And so that's interesting, like that sorry, to go back to your like question you asked on like the dynamic versus typed or static languages, that's like interesting in some sense, but I don't want to overstate what Dynamo does there. I do think it eliminates a class of problems. It eliminates the problem of I issued a query to Elasticsearch and sometimes it takes 10 milliseconds and sometimes it takes a minute. You know, and it's like the same query or just like a different parameter or a different data shape in the background. Like you don't have that problem at all with Dynamo. Every query you do to Dynamo is going to be like within a fairly bounded time window. So you'll get a response quickly. And it might even be an error response saying, hey, you're overloading our database, you're throttled, rather than just being like a super slow query, right? But the one thing I would say is like sometimes because of how Dynamo is structured, like if you have an access pattern where you just by nature need to read a lot of records and filter them out or something like that, that access pattern as a whole can take a while because maybe you need to issue a lot of requests to Dynamo to satisfy that access pattern. So it's sort of like the individual request to Dynamo is always going to be sort of time bounded within this very narrow window. But it could mean your entire operation that you're doing, it still can be slow. And I do want to make that distinction.
You're kind of forced to do multiple requests to get the data that you want.
Potentially, yeah. And the reason I make that distinction is sometimes people are like, man, Dynamo is so fast, like you can do whatever you want with it. And it's like, no, you can't do whatever you want with it. You can only do certain things. And because you can only do those certain things are guaranteed to be fast. But if you have other things that don't really fit into that, like now you need to compose lots of those things together.
I recently wrote a course on SQL for boot dev. And one of the interesting things about SQL, and it's not even, well, it is kind of, I don't want to mix up like SQL, the language, and like kind of the theory behind relational databases. But like the theory behind relational databases is actually interesting. And it's very like academic and theoretical in the sense that like you can structure your data in such and such a way. And we're going to like, quote, the word we use is normalize, right? We're going to normalize the data so that we're like never storing things twice. And everything can be related in a proper and sane way. And then we can query, like once the data is modeled in that relational way, we can query it however we want. And it's like insanely flexible, right? Like as long as you model the data correctly up front, everything's super flexible. And the nice thing about that when you're building like web apps, for example, is you get the data model right. And now your application logic, like what you want to actually happen for the end user, you could change that very quickly. Like one day it's doing X and then your customers complain, you just change it to Y. You don't have to like go re-architect your database. The problem with that is like, it's all really great in theory, but the practicality of like keeping those queries that go into this standard model of data fast is actually like really, really hard. And like these big databases like Postgres and MySQL and even like Cockroach, which is trying to like do it horizontally scaling, have a hard time. And so my understanding is like the philosophy behind something like Dynamo is like, well, okay, we get that like, you know, the theory behind database normalization is super useful, but in the practical sense, we've seen how slow it can be for certain use cases. And is that like an explicit trade-off in your mind of like, we're doing this for practical reasons, we're doing this for speed, we're doing this for scale?
Like you're saying, like that flexibility is nice, but then it comes with like this sort of unknown cost, or like it depends like on how sort of diligent you are about using the freedom that you have, right? Because the problem with like any relational query is it's like sort of unbounded in terms of how many rows it can go across, right? If you do like, hey, I want to find, like for you, which users have watched the most amount of video or completed the most lessons, right? And now you need to probably need to join across some tables. You need to do a group by on that user ID and do like a sum on or a count on the number of rows they've done, or maybe sum on the total video time, things like that. Which if you have 10 rows, it has to read 10 rows. If you now have 10 million rows, now it has to read 10 million rows. Like, and there's no way around that. So like there's this unbounded nature of it, especially when you're talking about aggregations or potentially joins, different things like that, that can just give you like significant variability in your performance. Where like Dynamo doesn't have that. Like partly because Dynamo doesn't do aggregations. You can't do any aggregations in Dynamo. Like you just have to read the data back and get it. It also limits on how much data you can read in a single request. So that's 1 meg of data. So you just can't do anything more around that. So, I mean, one thing is like it sort of pushes those constraints up front for you and like makes you think about those and just plan around them in a way that you could do in a relational database as well, but people just often don't because they have the freedom to sort of do whatever they want with it, you know? And the other thing, like related to that is Dynamo doesn't have a query planner, right? Like you're basically getting just direct access to items and sort of like the indexes themselves, rather than having like this indirection layer of the query planner. It's doing a lot of that work for you. And that was something that was kind of eye-opening for me when I came to Dynamo, because I didn't really understand that much how databases worked. I knew SQL pretty well and could do that stuff, but didn't like understand what was going on. And one thing I really like about Dynamo is it just like gives you a better intuition on how databases work now. And like, even if you go back to a relational database or Elasticsearch or something like that, you just get a sense for like, ooh, that's going to be an extensive thing because I know how much data it's touching or potentially touching and the transformations it has to do and just like all those sorts of different things. And it gives you like a little bit of a feel for that, even if you don't end up sort of going all in on Dynamo.
Okay. Yeah, that makes sense. So I want to circle back to query planning in just a second, but I also just realized that like, I don't think I did your original intro justice. Like people don't realize like, you wrote the DynamoDB book. Like you're the DynamoDB guy. We don't skimp on the quality of the guests on this show. So you're not just hearing some random person that's like used DynamoDB, talk about DynamoDB. Like Alex DeBrie wrote the DynamoDB book. You can go check it out. I'll drop a link to the description below, and then also we'll plug it again at the end. But I just wanted to make sure that
yeah, thanks. I appreciate it. And like, yeah, it's kind of weird. I kind of fell into it by accident. Like I don't have like a deep systems training. I actually went to law school and like I'm like a self-taught developer overall. So like I don't have like that deep thing, but just like, again, sort of fell into it in the serverless world. Watched some videos by a guy named Rick Houlihan that used to work for Dynamo, now works for Mongo. And then just like talked with some other people and sort of just like kept going down that Dynamo route. And the one thing I like about Dynamo is it is very understandable. I feel like you need to learn like 4 or 5 rules and you learn how it works and you can apply it in all these different ways. And for whatever reason, a lot of people don't like to learn those 4 or 5 rules. Then it keeps me busy, I guess.
Learning is hard.
Yeah, exactly. So it's like very predictable, and just like the amount of, or like the number of factors that go into any one Dynamo query or a data model, just like way fewer than a relational database where you have to worry about how many connections, how big are like things they're doing, how big is my buffer pool, are we doing full app queries on the hour or something like that that's slowing everything down. Just like a bunch of different factors there that sort of don't apply in the Dynamo world and can help you predict performance in a nice way. So I like that aspect of it.
I want to just circle back really quick to that SQL build or that query builder part that you mentioned, because that's really fascinating to me. When I write a SQL query, an SQL query, I'm writing this language, right? Structured query language. And the purpose of the language is to give me this like really flexible way, like express how I want to extract data from a system. But a lot of things support SQL. Postgres, MySQL, SQLite. I don't know. There's like SQL layers on top of even like NoSQL databases.
DynamoDB supports SQL unbelievably. Yeah.
Right. Like
so,
what?
Go ahead.
You just got to write like SQL all the time. What actually happens when the SQL runs is so dependent on the system underneath. And I think sometimes we don't realize that because like, you know, when you're writing a language like C, pretty close to the metal, kind of know what's going on. You're compiling for a specific architecture on a machine. And like, obviously it's still higher level than like assembly, but whatever. But like, you know, like when you compare it to Python, like you really get kind of what's going on at the machine level. With SQL, I think it's like actually this really high abstraction layer that sometimes we forget, because I think sometimes we compare SQL to like an ORM. We're like, oh, SQL is like the lower level thing that we're doing. But really, there is this entire layer of abstraction that's going on. And figuring out what's going on underneath SQL is exactly like you said. You need this like query planning tool. So for example, boot dev, when we have a query that we see is consistently taking a long time, say like 2 seconds to complete, we'll go in and we'll look at the query planner for the tool and see like what's actually happening, which indexes are being hit, right? What's the big O complexity of the different stages of this SQL query that's being run? Because it's actually not obvious from the SQL itself sometimes. It sounds like with Dynamo, you maybe don't need that query planner. Is that what I'm understanding?
There just like isn't a query planner. So like with a relational database, and this is why I say Mongo and Elasticsearch are actually like more similar to Postgres and MySQL than they are to Dynamo, is like both of them have a query planner layer where like you're going to say what data you want back, and then it's going to parse that. There's something in between the physical data and you, and it's going to parse that out and say like, okay, based on that, it has these three filters, it has these 2 joins and things like that. It might look at some table statistics that it's been maintaining about like cardinality of different values in a certain table or things like that, or like how many values are in this table to decide which kind of join to do, when to do that join, when to apply the filters, all these different things, and sort of choosing how to do that, and then going and executing that particular thing, right? So there's this layer between you on that. And based on that, it can be hard to understand, like, are the statistics bad and it's sort of using the wrong index? Maybe it doesn't know enough about my data or there's this quirk in my data that would make it run faster if it sort of knew about that, but it just doesn't know about it. Or like, is it using the wrong type of join? Or is it just like, it's hitting too much data? I wrote sort of a bad query and didn't realize what it's doing there. With Dynamo, there's not a query layer, right? Like the API you're doing are like basically direct access to your index. So you have like your key value type operations, get item, put item, update item, delete item. You know, if you have a B-tree index, you understand that's operating on a single item. You know, it's ologin to find that particular item, and then you just operate on it. And then there's a query operation that basically says, start at this record and read a contiguous set of items till this record, till this is true, right? Or until I hit 10 items, or until you hit a meg, or whatever conditions you want to have on that. And that, again, is just like reading a B-tree index. So it's more like direct access to a B-tree than it is like this intermediate layer that's saying like, okay, there are these 5 different indexes that I sort of need to work. And because of that, you don't get sort of like index intersection or joins or like some nice fancy things that your query planner can do. But because of that, you do get like the predictability aspect of that, again, that makes Dynamo attractive.
That scan operation that you just mentioned seemed to me to be kind of like the unique thing about BigTable when I was using it. It would be like, you get like this order and lookup to a row, and then we'd like scan some number of rows, usually like you said, until like the key changes to some value, and like read all of those rows out.
Yep.
Is that usually timestamps? Is it usually like go look up a thing by a key and then we want like the date range from here to here?
Very often timestamps. That's going to be the big one. Maybe alphabetical type things for certain things, but like timestamp is going to be the most common one for that. And like, you'll be surprised about how many of your access patterns are manipulate an individual record or retrieve a contiguous set of records using this single filter, like this user's most recent 10 things or
order by
things.
This thing.
Exactly. Like so like Dynamo's not flexible, but you'd be surprised. Like the more sort of apps you build, you sort of just realize, hey, these are like the same 5 patterns I keep using over and over. And like I can actually sort of plan for those and model my Dynamo correctly for that in a lot of cases.
Thinking of like the users table on boot dev or something. And like, maybe this is an unfair comparison because maybe you wouldn't throw a users table in there. Let me think of something else. Like, okay, like lessons. Like on boot dev, we've got the concept of lessons, right? And like as a user, you complete lessons. And there's a few different timestamps that are like on that record. One is when the lesson was completed at, and one is like when the solution was viewed at. So like if the student kind of cheated, quote unquote, and like viewed the solution. You want to order by both of those sometimes.
For a particular customer or across larger groups either?
Single player, so like single user, 2 different timestamps on the same record. We're going to want to order by both of those. Is there an easy way to store that data once and do 2 different order by queries? Or am I basically restricted to like copying this data into 2 different rows?
So that's where secondary indexes will work. Like, so you can have your main table and maybe you have a partition key of user ID that's going to split your data across these different partitions and sort of group them by that value. And then you have what's called a sort key, maybe on completed at, right? And now if you go to your main table and you say, hey, give me Lane's records, give me the 10 most recent ones he's completed, that's going to hit on my main table. And now you say, oh, but I also want to sort at different times by solution viewed at one. You can create a secondary index where the partition key again is that user ID, but now the sort key on the secondary index is that solution viewed at thing and get that. So now again, it's going to what's going to do when you write that record to your table, it's going to write it to your main table and then asynchronously replicate it to your secondary index as well and allow you to query on that sort of pattern, right? And
it's like a managed copy.
Yes, exactly.
It's like a copy that the system takes care of for you rather than like your application code having to do that.
Yeah. So in some sense, you know, it's like an index in a relational database. In some ways, you know, it gives you different ways to access your data. I'd say the big difference would be, hey, it's going to be on different infrastructure somewhere else that you then query directly using that secondary index. But it feels the same for you. You only have to write that record once and it's going to handle copying it for you. Yeah.
That's like that implementation detail is abstracted away from you as the user of Dynamo. Okay, that makes a lot of sense to me. One last question I have about Dynamo before I do want to talk a little bit about your consulting work over the last few years. I think that'll be really interesting. But this last question about Dynamo is like, How do you think about the cost of Dynamo, and like, when is it cheaper to use it, and what are the common gotchas for it being more expensive?
It's hard to think about cost because like it is a managed service, and so people talk about like total cost of ownership and stuff like that. And if you don't have someone that's sort of like managing this for you, how much are you saving that way, or things like that? I would say like one thing that's nice about Dynamo is you can scale your capacity up and down quite easily. Like you can do that very regularly. And so if you have a spike of traffic, you can scale it up to handle that. If it goes down, you can scale that back down, which you couldn't do in a relational database, right? Usually you need to sort of provision for the peak, and that's where it is. And then you have like super low utilization.
Oh, this is interesting to me. I have a question. So you actually, I was imagining it as this like magic control plane where you didn't have to think about infrastructure at all. Do you have to kind of at least somewhat think about the provisioning for your like cluster or whatever?
So there's two billing modes for Dynamo. One is the original one is the provisioned one where Dynamo billing is like a thing in itself. But basically in Dynamo, you're going to get charged based on read capacity units and write capacity units. So like if you're reading 4 kilobytes of data, that's a read capacity unit. If you're writing a kilobyte of data, that's a write capacity unit. If you write 5 kilobytes of data, they'll charge you 5 write capacity units, right? So it's all like sort of based in those sorts of things. So the provision mode is you say in advance, this is how much capacity I want on a per second basis for my table. And that could be 5 write units and 2,000 read units. And that can change all the time throughout the day as you need to. You just set that to whatever you want it to be. So like that, you're sort of like managing the capacity for that. If you happen to exceed it on a per second basis, you'll just get a 500 back, and it'll say, hey, you're being throttled right here.
So you'd be like, I'm not spending more than this. This is like the amount I want to spend. Give me that.
Yep.
Okay, cool.
Yep. The newer one, this is 2019, I think, is basically on demand mode, where you are paying per individual read and write to DynamoDB in like a truly like fully serverless way. Basically, like, if you have 0 traffic, you're not paying for anything. You're paying for data storage if you have data storage, but you can scale down all the way to 0, and it's not going to charge you anything for that. It scales up pretty rapidly. Like basically the scaling, the way it works is like it'll scale essentially instantaneously to 2 times your previous peak, and you won't see any your previous peak, right? So if you have like peak of traffic comes in and you're doing 5,000 reads per second, and then it goes back down to 200 and it stays there for 6 months, and then you come back and do 5,000 again, it'll handle that fine. It'll go up to 10,000 really fine. If it doubles, if it goes beyond doubling in like a very short period of time, we're talking like, 5 to 30 minutes, then it'll take a little bit of time to sort of scale up past that. And so that on-demand mode is like, now it's totally set it and forget it, right? You like don't have to sort of think about that at all. It's just going to charge you per read and write that you do to Dynamo in that case.
I'm guessing on demand is more popular.
It depends on sort of who you are. Like if you're in like sort of the serverless world, smaller apps and startups, I think most people are like, hey, the cost of dealing with that is just like not worth it. But if you're like, there's people that are doing millions of requests per second against Dynamo and have petabytes of data against Dynamo. And like in that case, it probably makes sense to have someone think a little bit and set up auto scaling, especially if you have like fairly predictable like daytime patterns, right? Where usage goes up during the day, goes down overnight, like manage sort of some scaling there. Basically the threshold the utilization threshold of like, should you do on demand versus provisioned is if you can do better than 17% utilization of your capacity, it makes sense to do provisioned. That'll be cheaper, which sounds kind of low. 17%, you're like, what? But it's actually like, if you look at your database utilization over the entire day or things like that, it's actually like not great. A lot of like single digit,
I get concerned anytime any database is over 50% on any metric.
Yeah,
like
exactly.
To me feels like 20%. Yeah. Like
exactly. Right. So then it's like, okay, how much time is it worth to even think about that sort of problem to eke out some utilization versus just like set it to on demand and not even worry about it at all at that point. So then like for a lot of folks, I always recommend on demand, unless it's like, I'm always like, hey, figure out what your Dynamo bill is going to be roughly and figure out if like cutting that in half would be super meaningful to you. And if it's not, then like I would say don't even worry about it because it's not going to matter. Because some people have like $200 a month Dynamo bills, and it's like if you save $100 a month but now you have to like manage your provision throughput. Like that's just not worth it, you know?
Which like to like a new developer or like an indie developer that's just like building a side app, like, yeah, saving $200 a month feels huge. Like that's like 20 Netflix subscriptions or something. I don't know, whatever.
Your Dynamo bill is not going to be $200 a month unless you have like some decent traffic on it, you know?
Right.
So, yeah.
But no, the point I'm making is just like, I'm thinking of like where boot dev is now. Like I'm employing several full-time engineers. Like, my database costs at the moment are on that order. It's like a couple $100 a month. And it's like the last thing I'm worried about, right? If it creeped up to a couple $1,000s a month, then I'd be concerned maybe and think about how we could maybe change some things. But you're comparing to like salaries. Those amounts don't matter too much.
Yep, totally. So I forgot what road we were going down before we took like this billing side road. What were we talking about? Do you remember?
Well, no. I just said that, I'd had questions about like how you kind of plan for expenses. Right.
Yep.
And how you manage that. And that was interesting because you talked about provisioning, and I was kind of under the impression that it was my understanding of S3, for example, or Google Cloud Storage is like, there is no such thing as provisioning. I don't have to worry about it at all. I'm just hitting the API, right? It sounds like with Dynamo, it's just a slight, like just a little more work than that.
It's either way. Like you can do that on-demand thing. And you can also do this trick with on-demand that basically like gives you a fake peak of like 40,000 reads and writes per second, which like most people are never going to come close to, and then immediately scale it back down. And that means you're basically in sort of S3 world, right? Where you never have to worry about scaling and getting throttled and stuff like that. You're just doing pay-per-use like you would S3. So like you can do that if you want to. If you're more cost conscious or things like that, then you can think about it.
Sounds like such a hack. Like why would, if AWS is able to do that, like why wouldn't that just be like the out of the box option?
I think they actually kind of don't like doing it because, and don't love when people do it because actually Dynamo's partitioning your data under the scenes, and it's in choosing how many partitions you have under the scenes, there are like a couple different factors. It's like how much storage do you have? Like basically every 10 gigabytes of storage, they're going to add a new partition. Or it's based on how much throughput you have. So even if you have like a fairly small table, but it's like super hot, it's going to have more partitions just to spread that across more partitions. So what you're doing when you're scaling it up to 40,000 reads and writes and scaling it back down is they're making a ton of these tiny little partitions all over the place that are just hanging around forever. And if you're doing like tiny amounts of traffic, it's like, now we have to like sort of keep these partitions around.
Yeah, they probably hate that. It like ups their costs and stuff.
Oh, yeah, a little bit. I've sort of asked them like, is that a big annoyance for you? And they said it's actually like not that big of a deal because like, you know, what they have is like these giant storage nodes. They're just a fleet of storage nodes, right? And each storage node is holding hundreds of partitions from all different customers, all that different things. And they're sort of moving those storage nodes around based on like, hey, this one doesn't have that much actual storage. We can like pack it with one that's like a little denser storage, but maybe doesn't have as many requests. So they're like doing that balancing. So if you have a partition that basically has no data and no requests, like it's not hurting them that much, but it's like just a lot of metadata they're keeping around.
This is like this sounds like it's probably like an undocumented product feature that honestly could go away if they wanted it to. Like
it's definite. Yeah. It's like there are no guarantees on how many partitions Dynamo is going to make behind the scenes, whether those are like going to like currently they don't recombine partitions, and like if they split a partition, that's split forever, but they could theoretically. Like there are no guarantees on that. Basically what it is like a quirk of people reading the documentation very carefully, doing some testing, and then realize, okay, if you do like basically the trick is creating your new table as provision mode, setting it to 40,000 reads and writes, which now is like your fake peak that you've ever hit. And then you immediately switch it to on-demand mode. So now you're not actually paying for those 40,000 reads and writes for like a long time, just like a few seconds. Now you switch it to on-demand mode, and now you have a bajillion partitions, but you're only paying for reads and writes as they come in.
Kind of engineering hacks are so fun. Like, I don't know if you ever did you ever play Super Mario 64?
Oh man, I'm playing with that with my kids right now. It's so much fun.
It's so good. Yeah. But for some reason on like TikTok and YouTube, I just get recommended like speed runs of Super Mario 64, and you can like reverse long jump backwards into a door enough times that like your speed vector gets so high that you just like go through the door. And this is like one of those things. It's like, you just kind of like play with it long enough that you figure out what's going on behind the scenes. It's not part of the API contracts, right? Yeah. But like you can get these things going. I'm not gonna like recommend that.
How do people find that? That's amazing. Like
I don't know.
That's more amazing than like someone reading the docs carefully. It's like, what were you doing that you were just backflipping a bunch, you know? But whatever. Yeah.
Okay, amazing. Thank you so much. That was like going over Dynamo. Not only was interesting to me because I haven't really used it very much, but I think it'll be awesome for the audience. I want to switch gears for just maybe like 10 or 15 minutes, the last little bit of this pod. Talk about your experience consulting. What was your last full-time job before you started the freelancing stuff?
So my last full-time job before I started freelancing was at Serverless Framework. Basically, I quit that in January 2020, and I was like, I'm going to write the DynamoDB book, because I like started to kind of write it while I had a full-time job, and I'm just like, all my creative energy is going towards my job, and I have nothing left to do the writing. So I couldn't do that. I thought there was a market for it, and I'm like, I'm gonna quit and do this. So I quit in January 2020, and most of the next like 4 months was writing the book. I released that in April, which was like 2 weeks after like COVID shut everything down. And I'm just like, is anyone going to spend any money? Like, did I just like totally blow this whole thing? But like that went fine. So the first couple months were about the book. And then like there was book sales, there was like sort of training and additional help on that sort of thing. And then actually like in August of that year, I did join a company. It was called Steady. I worked there for like 5 or 6 months, and then decided I want to get back into just like being on my own. I sort of liked that independence once I had gotten that taste. So have now been full-time independent since January 2021 on that. So I say most of the last 4 years with that little stint in the middle there.
Notice you use the word consulting. Most like say less than 5 years of experience developers who are kind of striking out on their own, they probably wouldn't call themselves consultants. They'd call themselves like freelancers. And they're like kind of hopping into a project, writing a bunch of code, usually for like a very small company. How does what you're doing with consulting, is that different?
Yeah, I would say especially like the first couple of years I was consulting, it was more advisory consulting, training type stuff. So like almost no hands-on code for a while. Whereas like, hey, we want to use Dynamo. Would you help us understand Dynamo? Which could be a training workshop. It could be, we have this specific data model that we want to design, and would you just help us walk through the process of how to design that data model and think about it? Because with Dynamo, you have to do a lot more upfront design to like design your data model. Like you were talking about database normalization earlier, and it's like with a relational database, you sort of like normalize your data first and then think, what are the queries I need to access my data? With Dynamo, it's like, what are the queries I need to access my data, and how do I design my table to handle those queries, right? So it's a lot of upfront design and just like getting people to understand that shift. So that was a lot of it. One thing that I like that because it's like very flexible, and I see a lot of different things and just like helping people that way. But I didn't get to do as much hands-on code, which is like what I really like doing. I miss that aspect of it. So now I've taken on more like hands-on work in the last year and a half, which I like that. So now it's like a balance of like some advisory stuff, some hands-on code.
You ever see yourself going back to a full-time job?
It's like I was talking about with my friend this the other day. It's hard to imagine being independent for like 40 years. But I also like, and I really like the flexibility and independence of being on my own. I don't know. I want to be independent as long as I can. And like my wife loves it. And like, you know, we have kids, and like if they have a school break or, you know, over the summer, we can like go on road trips somewhere or something like that very easily. I like that aspect of it. I don't know. The biggest thing I tell people I miss is just like working as part of a team, and like the camaraderie there, and also like building towards something bigger than yourself, and like the joy when it like takes off and like all that stuff. Those feelings I miss when I'm not like working as part of a team as much.
Do you have any entrepreneurial urges? Like, would you ever start your own like product?
Yeah, potentially. I don't think I'm like, I don't want to like self-talk badly, but like, I don't think I'm like super great at like the 0 to 1 type phase of just like purely starting it from zero and doing it myself. So potentially, I also think it just gets harder as you get like more established in your life. Like we have 4 kids and like, you know, house and all the things. And it's just like, now it's like, it's hard to start from zero and like work your way up to like, you know, ramen profitable and all that sort of thing. So it's just like a harder bar there. So maybe I like the idea of it, but see, I haven't had anything that like draws my attention in that way, or I thought would be like worthwhile to go do that yet.
Crazy project ideas yet?
Yeah, not yet. Yeah.
Cool. We'll see what comes the next couple of years. Sounds exciting. What's like the one takeaway if there's people listening to this pod that are thinking about either freelancing or consulting, what's like the big thing they should think about before jumping into that world?
How will you get clients? Think about how you will get clients. And specifically, like you want to get clients that want to work with you because you're lane and not because you are a developer that knows Python or something like that. That like someone that wants to work with you specifically, because that gives you some amount of like pricing power and just like selectivity of just like making sure it's the right fit for you and things like that. I think you want to try to avoid hourly billing. I hate hourly billing. I said I was a lawyer. That was like my least favorite part of being a lawyer, was like keeping track of my hours. Like I'm a, school kid or something like that. Like I just did not like tracking all my hours. And I think you don't want to track your hours as a consultant either, because it ruins your incentive to get better, right? If you get more efficient, you actually like lose money, which is just silly. But then you also kind of feel bad. It's just like a bad situation. So figure out how you're going to get clients. I think on the internet, that's a lot of ways easier than ever, but also harder than ever because you're competing with a lot of people. But you can definitely like write or do projects or do things where people are like, man, I want to work with that specific person. They know this, and I think they can do a good job. Or you can have evidence of just like, I've built this before, I can do it for you as well. But like that's what you want to do, is like figure out some way to get clients. And mine has been mostly inbound based on like Dynamo and serverless and AWS stuff that I've written over the years, and also clients that I've worked with. But like my brother-in-law does consulting. He's like machine learning guy, and he does a lot of word of mouth or attending like local things in the area where people have a computer vision problem. And I realize like he's one of the few people in the area that can help him with that particular problem. So like, there are different ways to get clients, but think really hard about how you're going to get clients, because I've seen a few people go out and then they have like no way to get clients, and they don't want to go like pound the pavement or anything like that. And it's just like, it's really hard then, it's really hard in that sense.
In the freelancing world, I feel like there's not as much of a like necessary components around authority. But in the consulting world, to me, it sounds like it's very important. Was publishing the book a really key part of your ability to make a transition into consulting?
And it was, I already had like written a bunch of Dynamo stuff online. I had like spoken at reInvent and a few other conferences about Dynamo before doing the Dynamo book. So like I had some authority there, and then it sort of just like solidified me another way. And just like, it helps that Dynamo is like a niche area. Like if you wrote a book on MySQL, there are a bajillion other books and things on MySQL. No one had written anything on Dynamo at all. So it just like sort of helped in that particular sense. And so I do feel like I got lucky, just like right place, right time on some of that stuff. But I do think that, writing online and then having a bigger piece like a book, I think that can help you for sure.
Fantastic. Well, Thanks again for coming on. This has been a lot of fun. I always love when we do an episode on something entirely new. I mean, we're getting up there. I don't actually know. This is going to be about episode 40. But yeah, like it's, it's fun to do some original stuff. There's a last thing. What do you want to plug? Is there anything, where's the book? Where can people find you? That kind of stuff.
Yeah, I'd say if you want the book, dynamodbbook.com, you can find that out. You can find me on Twitter, Alex B. DeBrie, or my website, alexdebrie.com, things like that. But most of all, just reach out if you want to talk about Dynamo. I kind of rambled, I think, in different spots today. But if you want if you want to talk about or understand like when Dynamo can be right for you or not, or like what are the sort of pros and cons and things like that, I try to be fair on that aspect. Like I do love Dynamo, so there's that aspect of it. But I do try to be fair about like thinking about trade-offs and realizing it's not right for every situation. So feel free to reach out anytime. Like, thanks for having me on, Lane. This has been a lot of fun to get to chat with you. Love the podcast. So
Thanks, Alex. Yeah, we'll talk to you later, man. Bye-bye.
Cool. Thanks, Lane. See ya.